Hello everybody, in this question we have a curve C traced out by the given vector valued function rt, and t is changing from 0 to 2, and we have three parts in this question. In the first part it says determine whether the curve is parameterized by arc length. If it does not, give a parameterization ps that uses arc length as a parameter, and it says like don't forget to include the domain of the arc length parameter s. Okay, and let's start with this part. So rt is given by this vector valued function 1 minus 2t, 2 times t to the 3 over 2, and then 6 times t to the 3 over 2, and t is changing from 0 to 2. Okay, and a vector valued function, if we parameterize a curve C with a vector valued function, that parameterization is an arc length parameterization if and only if the curve is a unit speed curve. What do I mean by that? If we consider this rt as position function, what is the speed? Okay, so if you take the derivative of this, you get velocity. I'm just trying to make sense of these things in your minds, and that's why I'm trying to explain them by like physical quantities. So this position vector, you should think this as a position vector, and then you take the derivative, you get velocity, right? But we are looking for speed. What I said, a parameterization is an arc length parameterization if and only if it is a unit speed parameterization. So velocity is not speed. Speed is the magnitude of the velocity. Okay, so now we are taking the derivative. Okay, this is gonna be what? This is gonna be speed. So take the derivative of, you should take the derivative of each coordinate. So this is gonna be minus 2, and then derivative of this part is gonna be 2 times 3 over 2 times t to the 1 over 2, and 2 and 3 over 2 will be, when you multiply them, you get 3. So this is 3 times t to the 1 over 2, and then if you do the same thing, you will get 9 times t to the 1 over 2 by taking the derivative third coordinate. And now we need to find the magnitude, which is kind of speed. Okay, so the magnitude is like you square each coordinate and add them up, and then take the square root. So it's going to be minus 2 squared plus 3 times t to the 1 over 2 squared, and then I have an email, sorry about this, I didn't turn off my Wi-Fi. Let me turn off this. Okay, so and then we have the square of the third coordinate, and then we take the square root. Okay, so if you do that, you will get like 4 plus 9t, right? And then 81t. So this is gonna be 4 plus 90t squared. Okay, you take the square root of that, and as we see, this thing is not 1. Okay, so this is not 1 for all t. So if it is not 1, it is not a unit speed curve. That means it is not parameterized by arc length. So the curve is not parameterized by arc length. So what do we do? Now we have to parameterize this curve by arc length, because this is what we are asked to do. And how we do that? Okay, so in order to parameterize by arc length, we need to find the first arc length function, okay, as a function of t. So let's find that. So let's call it s. Okay, and it's gonna be, so how do you find the length? So if you integrate the speed, okay, you will get the total distance traveled by the particle or whatever. Okay, and now we need to take the integral of this magnitude of r prime t to find the arc length as a function of t. Okay, so it is from 0 to an arbitrary t, and we are going to integrate this, but since I use t here, I'm going to use another parameter. I will write tau. Okay, so d tau. So what was this? We found that in the first part it was the square root of 4 plus 90t. Now we replace it with tau, so it's going to be 0 to t square root of 4 plus 90 tau d tau. Okay, now we need to integrate this quantity, and in here we can do a u substitution. Okay, u sub, and that substitution is going to be u equal to 4 plus 90 tau, and then if you take the derivative differential, you get like du is equal to 90 d tau. That means d tau is 1 over 90 times du. Okay, and also we need to change these boundaries because now we are going to use our variable u. So when t is 0, okay, when tau is 0, if tau is 0, so this is the lower boundary of the integral. Okay, so if this is 0, then we have u equal to 4, and if tau is equal to t, which is, I'm sorry for that, I have a neighbor and he has a dog, so like it will go away in a second of time. Like, I'm sorry, like we are living in a weird situation in this time of the world and we have a pandemic, but I'm trying to do my best. Okay, so I'm at my home, I'm like any of you. Okay, so yeah, he stopped. Okay, so tau is equal to t, and then we have when tau is equal to t, we have like u equal to 4 plus 90t. Okay, so then this is gonna be from 4, which is the lower boundary when we change this variable, when we do u substitution, and upper boundary is like 4 plus 90t, and then now it's going to be square root of u 1 over 90 du. Okay, so what is u? This is just u to the 1 over 2, and now this is a simple thing to integrate, so it is from 4 to 490t, u to the 1 over 2, and then we have 1 over 90 and then du. So if we integrate this, this is going to be like 1 over 90 times 2 over 3, u to the 3 over 2, and we have 4 and then 4 plus 90t. Okay, so this is going to be if you like substitute this boundaries, you will get 1, and if you do simplification here, for example, this is going to be 45 and this is going to be 1 if you divide both numerator and denominator is 2, and if you multiply 3 with 45, you will get 1 over 135 here. Okay, and then if you like put this lower and upper boundaries, you will get like 4 plus 90t 3 to the 3 over 2 with the power 3 over 2, and then minus 8 over 135. Okay, so this is our arc length s as a function of t. Okay, now our curve is parameterized with rt, and t was the parameter here, right? Now we know the relation between t and s, which is arc length. Okay, so if I want to parameterize by arc length, I should solve t in terms of arc length. I should solve t in terms of arc length, which is s. Okay, I should solve t in terms of s, and then I should substitute t to rt. Okay, so let's do that. So now we have found that, so let's write it. Find t in terms of s. Okay, so we have s equal to 1 over 135, 4 plus 90t 3 over 2, and then 8 over 135. Okay, so we need to add 8 over 135 to both sides. When we do that, we have s plus 8 over 135, and this is going to be 1 over 135, 4 plus 90t to the 3 over 2. Okay, now let's multiply both sides with 135 because we want to get rid of this denominator here. Okay, so it's going to be 135s plus 8 equal to 4 plus 90t to the 3 over 2. Okay, so I want to get rid of this 3 over 2 power, then that means I should take the 2 over 3rd power of both sides. Okay, take 2 over 3 power of both sides. So this is going to be 135s plus 8 to the 2 over 3, and that's going to be 4 plus 90t. And now we should subtract 4 from both sides and then divide to 90 to get t on the right side. Okay, so subtract 4 and divide to 90. Okay, so we get 135s plus 8 to the 2 over 3 minus 4 divided by 90, okay, is equal to t. So we found our t. Now we will substitute this t. So our equation rt is here. Okay, so now we are gonna change this t with this t we found here. Okay, so now, but we can't use this, we can't use the same letter. Okay, we can't use r anymore. So because if you write rs, that means you should replace t directly with s. Okay, it should be t equal to s, but in here t is not equal to s, so this is a different parameterization. So that means we need to use a different letter, and the letter suggested in the question was p, so it's going to be ps. Okay, let's move it here because it's going to be a long expression. And before that, let's write our rt here. Okay, maybe I should copy from here directly. So let's erase this and then take this. Okay, copy it and let's paste it here. Okay, so we paste it here. So this is our rt. Now we will replace this t here with this expression given by s. Okay, so then ps is going to be 1 minus 2 times. Okay, so our expression is 135 s plus 8 to the 2 over 3 minus 4 divided by 90. Okay, so this is the let's move this closer and then move this thing to here a little bit. Okay, so this is the first coordinate. We replace this t here, okay, with the given function there. Okay, and we will do the same thing for these t's here as well. So this will give us the arc length parameterization because s was arc length function. Okay, so it's going to be 2 times 135 s plus 8 to the 2 over 3 and minus 4 divided by 90 to 2 over 3. And then the other coordinate is going to be 6 times, again, 135 s plus 8 to the 2 over 3 minus 4 divided by 90 to 3 over 2. Okay, but as you remember, so in the question, in the first part, it says do not forget to write the boundaries of s, right? So this is arc length parameterization. So this is arc length parameterization for, this is an arc length parameterization for the curve C. Okay, so but we need to write the boundaries of s here. Okay, so if you recall, okay, we had this function here. So this is s in terms of t. Okay, let's copy this. Okay, So we had this s given by this function in terms of t. So we know that t was changing from 0 to 2, right? Then when t is equal to 0, okay, s is equal to 1 divided by 135, 4 plus 0, because 90 times 0 is 0, 3 over 2 minus 8 divided by 135, right? But if you take like third power of 4 and then take the square root, you will get 8. So this is just 8 over 135, and if you subtract 8 over 35, you will get 0. So this is just 0. Okay, so when t is equal to 0, s is equal to 0. But t is changing from 0 to 2. Sorry for that, I wrote 0 on the both sides, but it was 0. T is changing from 0 to 2. So when t is equal to 2, we have s is equal to 1 over 135, 4 plus 90 times 2, because t is 2, to the power 3 over 2, minus 8 over 135. Okay, so it is just 1 over 135, and this is going to be 184 to the 3 over 2 and minus 8. Okay, so this is the upper boundary for s. So s is changing from 0 to this quantity here. Okay, so it is this number here. So this is the interval for s for this arc length parameterization here. Okay, so now this finishes the first part of the question. We have our arc length parameterization, and we have the boundaries of the arc length parameter here. Okay, so that's how we solve the first part. And now we have the second part of the question. Let's remember what was the second part. In the second part, it says like, now you have this arc length parameterization, okay, and now you are asked to find the magnitude of the derivative of the arc length parameterization at s equal to root 2. Okay, but what did we say? We said like, if something is parameterized by arc length, then its speed should be always 1. Okay, so since this is parameterized by arc length, since this is an arc length parameterization, its speed should be 1. So this is 1. Okay, for all s. So hence this is equal to 1 when s is equal to root 2. So it doesn't matter whether s is equal to root 2 or not. So it is always 1 if it is parameterized by arc length. Okay, so this finishes the second part. And in the last part, okay, in the last part we are asked to find the length of the curve C. But you know, we find this arc length function. Okay, s was arc length function. Okay, that means it gives you the length of the segment of the curve from 0 to t, because we integrated from 0 to t right here. And now since we are asked to find the arc length, okay, so it is just the final length. So it's going to be s evaluated at 2. Okay, when t is equal to 2, we get length of the curve length of the curve C. Okay, and it is s2, and s2, we found s2, it is the upper boundary of the s, right? So this is the maximum value that s can get. So the Length of the curve is S2, and that is 1 divided by 135, 184 to 3 over 2, and minus 8. So this is the length of the curve. Okay, so this finishes all part of this question. Sorry for the inconvenience due to noises or like any other things, but I think you all understand that we are not living in our regular world, and we are trying very hard to keep things going on. Thank you for listening.